particular sequence. Only after closing the gate, LC gate, we need to clear the signal if it is in the en route path. Like that, between two variables, either the signal point, track circuit, or all the signaling gates, there is a particular relationship. They need to be operated in a predetermined sequence. And why do we follow this sequence? What is the purpose of following this sequence? If you clear the signal without closing,
movement, sir.
Safety.
To ensure safety.
yes, safety is the primary thing. If you close the just a minute. Just a minute. Hello. So we follow a predetermined sequence in operating the signal gates, and this sequence is followed to ensure the safety. So here, not only in signaling, in general, in day-to-day life also, you may be seeing some interlocking. Have you seen? There is a predetermined sequence in which we need to operate certain things. Suppose, for example, if you are going for a top floor in a lift, we need to close the doors of the lift, then only the lift is going to start. So like that, we are achieving a particular sequence in gears for ensuring the safety. Here in relay interlocking, we are going to ensure that if I am going to clear a signal, the conflicting signal is not cleared. Since this is a very vital point, this is proved in number of stages again and again. So in how many stages we are going to prove this one normally? In our circuits, in how many stages are we going to prove that the conflicting events doesn't take place at the same time? Can anyone please tell me? Hello, are you getting me or not?
अच्छा कोई चीज डिस्प्ले कर रहा है सर क्या?
Sir, are you
Is not available, sir.
Are you not able to see the screen? Just one.
We are not getting your screen, sir. Please.
We are not seeing any diagram, sir. Only cursor shown, sir.
Only voice.
Sir, your screen not visible, sir. Only voice.
Are you not able to see the screen?
No.
No, sir.
Sir, sir, not visible.
Completely blank.
1 minute. What do you see now?
Yes, sir.
Sir.
Now is okay.
Right. So these PPTs and all are available in the IRSET website. I hope you know how to get it. Or do you want me to tell me? All the PPTs of all the subjects are available in IRSET site. The IRSET site, once you open, is the IRSET site 10.195.2.19. Are you able to see the screen?
Yes, sir.
Yeah. Go to learning resource. In the learning resource, go to signaling resources. In that one, if you want lecture slides, you can go for signaling lecture slides. There, all subjects PPTs are available. Now we are seeing S12 subject. So you can download them. Not only this subject, all signal, telecom, all subjects are available. Not only the PPTs, there are a lot of videos and the IRSET notes also available. You can download all the soft copies. Okay. So here now we are seeing interlocking. Are you able to see the screen?
Yes.
Yes. You please tell me in how many stages in RRI we are going to prove the interlocking. Here I mean the interlocking means the conflicting events doesn't take place simultaneously. You might have seen a lot of the circuits. So in how many circuits we are going to prove that the conflicting events doesn't take place at the same time? Please tell me. Hello, are you getting me?
Yes, sir. Clear. Voice is clear, sir.
Yeah, but you are not responding to me.
Yes, sir.
Yeah. You tell me what do you prove in RR circuit? Or if someone is having all buttons in a NRR circuit, what are the things you are going to prove here in this circuit? Any one of these circuits? We are proving that if I am going to clear a signal or I am going to pick up the particular signal RR, the signals which are conflicting to the signal, those RRs are in down condition. In a similar way, when I am going to pick up a particular NRR of a signal, I am proving that all other routes that are conflicting to this particular route, those NRRs are in drop condition. So here I am proving that for the first time, the conflicting events doesn't take place simultaneously. And what do you prove in the UCR circuit? In route checking relay, while picking up the route checking relay, what are the things you are going to prove? Please tell me, anyone? Hello, are you able to get me or not?
Sir,
Crank
clear,
handles,
sir.
Yes, sir.
point
Voice is clear.
Point integration, sir.
Here our point of discussion is about the interlocking. So for this particular signal, if I am going to pick up the UCR, the conflicting signals UCRs I am going to prove in drop condition, or the conflicting signals ASRs in up condition. Any one of these condition I am going to prove. So this is ensuring that the conflicting events doesn't take place simultaneously. And I am going to prove for the final time in one more circuit. What is that circuit? Here our discussion is about interlocking. That means
Signal control circuit.
the signal.
UCR circuit, sir.
Yes.
UCR circuit, sir.
No, in the final HR circuit also we are going to prove that the conflicting signals ASRs are in up condition. So in these three stages, in the initial stage, when I'm going to initiate the route itself, I'm going to prove in NRR or RR stage. And later, while checking the route in the UCR stage also, we are going to prove for the second time. And finally, in the HR stage also, we are going to prove that the conflicting events doesn't take place simultaneously. If I am clearing for a particular signal, all the signals which are conflicting to that particular signal, those are not cleared, those are not taken off at the same time. I am going to prove in these three circuits. Is it clear?
Yes, sir.
Yes.
I request all of others to mute, only those who want to ask some doubt can unmute. After my speaking, please mute it off. So there are different types of interlocking. So we got the mechanical interlocking, the electromechanical, electrical or relay interlocking, and electronic interlocking. So all the new installations, what we are going to further will be of electronic interlocking type. And here we will be discussing only about this relay interlocking or electronic interlocking in this session. So how interlocking is achieved in mechanical interlocking?
lever frame.
Locking tray.
Through lever frames.
So in the locking tray, you got physically available. That means if I move a particular lever, that will obstruct or it may permit the other lever to move or not to move. So this we are going to achieve by means of mechanically direct locking between the gears, direct locking between the levers. Is that available in relay interlocking?
No.
Then how it is achieved in relay interlocking? So if I am going to take one
UCR circuit.
how in the UCR circuit? So here, if I move a lever number 1, suppose if it is conflicting to other signal which is controlled by lever number 2, then it ensures that if I am reversing this lever is not possible to reverse. I am ensuring the mechanical interlocking directly through levers. But how that is achieved in relay interlocking? We don't have any physical interlocking between the
UCR and HR, sir.
knobs or switches. Yes, we are achieving the
Direction relay
interlocking. We are achieving the interlocking. Direct how? Here directly we are
Direction
achieving
relays
levers.
We are using relays
Direction
contact.
relays are there, sir.
No, Mr. Sunil, what is that? What is your? I am not able to get you.
Direction relays are there, sir.
Directional relays. Yeah, I mean,
Yes.
you mean to say that this interlocking is achieved indirectly by means of relays. So in relays indirectly, what we are going to do? You are going to quantify each and every act. Suppose a knob is there. If the knob is in normal position, I am going to quantify that one by one relay, say NCR. If I am going to turn the knob to reverse, I am going to quantify that by another relay, RCR. So if the knob is in normal, this NCR relay will be in pickup status. If the knob is reversed, this RCR will be in pickup. In NCR circuit, I am going to prove that RCR is dropped, and similarly in the RCR circuit, I am going to prove that the NCR is dropped. So that means I am achieving the interlocking by means of using the relays in relay interlocking. Is it clear?
Yes.
Yes, sir.
Yes, sir.
And how it is being achieved in electronic interlocking in EA?
Through logic circuit, sir.
Logic.
Yes, the same circuits what we are going to use in relay interlocking, we are converting them into
Logic circuits.
equivalent Boolean circuits, and we are reducing the number of relays. That means most of them is done through the logic, and only the necessary relays which has to drive the gear, that only we are retaining it. And as per the latest policies, all the new stations we are going to have the electronic interlocking type. So above, if it is more than 500 roots, we will go with the metal to metal type of relays. Otherwise, generally, we are going with metal to carbon relays for all the electronic interlockings. So do you have any electronic interlocking with metal to metal in any of the zones? Yes? Hello?
No, sir.
Okay. So, but it is being permitted. So yeah, the electronic interlocking, we are going to get in all further new installations. So this is the type of interlocking, either it is mechanical or if it is electromechanical or relay interlocking or electronic interlocking. We are achieving the interlocking. So interlocking here, we mean that the conflicting events doesn't take place simultaneously. So particularly our interest in relay interlocking, how it is being achieved. So we are checking that one in the UCR stage. In the UCR stage, we are checking that the conflicting UCRs are in down condition. And again in the HR stage, we are checking that the conflicting signals ASRs are in up condition. And in the first stage, actually generally it is checked in RR stage or NRR stage. So here we see that in 3 stages, not in 2 stages, in 3 stages, the relay interlocking, we are checking that the conflicting events doesn't take place simultaneously. So the specification of the relay interlocking is IRS 36-87. So as per this specification, we are going to see some important points of that specification. And basically this relay interlocking, where the interlocking is achieved by means of relays, is of 2 types. One is root setting type and the other is non-root setting type. So what do you understand by non-root setting type?
We have to individually set the point to set करते हैं.
Yes, that means, so suppose a signal is available, I am going to take off that signal for a particular route. I'm going to take off the signal for a particular route. Whatever the points that are falling in that route, those has to be operated individually by the operator. So he has to set the points to the favorable position of the route. Then only it is possible to clear the signal in non-root setting type. The same thing in root setting type, how it will be? Suppose I want to take off a signal. This is a home signal. I want to take off for a loop line. I want to take for this loop line. So if I press, yes, if I press the signal button and that concerned root button, yeah, whatever the points that are going to fall, if they are in unfavorable position for this route, they are going to automatically operate and set to the favorable position of the route. How is it possible? How the route knows automatically I should operate the point?
LR circuit.
What is that?
LR circuit.
LR.
Yes. So we are going to initiate, depending upon what, how we are going to pick up the LR? Is NLR or RLR, for normal NLR and for reverse RLR to initiate that point. So how we are going to pick up that?
NRR.
Yes. So what does NLR says? Just 1 minute here. So NRR basically is meant for identifying the route. Suppose a signal is available, a signal is there, it can have a number of routes, 1, 2, 3. So for example, say it is having some n routes. For knowing the status of each route, we got two relays. One is NNR relay and the other is NRR relay. So what do you understand by NNR? That is route normal relay. That means no route has been initiated. It is normally in pickup status. When I am going to press the signal button along with that concerned route button, when I am selecting that particular route, I am going to pick up NRR and I am going to drop the NNR of that route. So NRR pickup state indicates that route has been initiated. So here, this NRR identifies the route. So what do you understand by route? So when I am going to clear the signal from one point, so up to what point I am giving the authority for the local pilot to move? From this signal to the next signal in advance, next stop signal in advance. I am giving the authority to move. So here, which defines the route, whether he has to go in this straight path or in this loop path, which is going to decide how the route is defined.
Point position.
Yes, the point position is going to identify the route. So once we have identified the route by this relay, we use this relay to further process the point operation. So that in this route, whatever the points that are falling, if they are in unfavorable position, we are going to operate them. We are going to initiate the operation of the points. So that we will be seeing in detail when we discuss about the point chain operation. So in the route relay interlocking of route setting type, the route is automatically set. That means the points, if they are in unfavorable position, they are going to be operated automatically. So in the non-route setting type, one has to physically operate the points to the favorable position and then clear the signal. So if you see the differences between the panel interlocking or not non-route setting type and the relay interlocking setting type. So these are the few differences. Here, panel interlocking. Yes, Mr. Joseph Soren, any doubt?
Yes, sir. No, sir.
Yes, tell me.
Okay, sir.
Right. So here the route is set by setting the points individually. That means the operator has to operate the point individually. So how he is going to operate the point individually? How he is going to operate the point?
Using crank.
Is it
Or
crank
hammer.
handle?
We use
Point button and common point button.
Point knob, sir.
Button, sir.
Yes,
Point
yes.
button.
we are using
Knob.
knobs.
Button of either.
So in how many ways can we operate a point? You please tell me.
By using knobs or buttons.
No, that means by sending the electric power electrically or by mechanical means, by hand cranking it, by mechanical means. So mechanically we do by using the crank handles, and electrically we are going to do either by turning the knob of the point from normal to reverse or reverse to normal, or by pressing the concerned point button along with the common button. This common button will be either for normal or for reverse. So when I press the concerned point button along with the common button for normal, this point is going to operate for normal position. If I press the common button for reverse along with the point button, this point is going to operate for reverse. Or if I have a knob, when I turn the knob for normal, the point is going to operate for normal position. And likewise. So that means here I can operate the point by two means, either electrically or mechanically. And what are the conditions that requires for it to operate? Suppose I want to operate the point electrically. What are the conditions it should satisfy? When I can operate the point?
An operate point if the route is clear and the track is not occupied.
Yes, the route is clear means that particular point which we are going to operate is not engaged in any of the routes. So how do you express this in the form of circuitry?
We are using SRs.
Yes. So we see that all the signal ASRs which are connected with that particular point, those should be in up condition, which indicates that this point is not locked in any of the route, or it can be locked in the overlap also. So we see that all the ASRs or OVSRs or wherever sectional route release is there, TLSRs and TRSRs of that concerned point are in up condition, so that that point is free. It is not engaged in any of the signal route or overlap. So if it is not associated with any of the route or overlap, is it sufficient to operate the point, or any other conditions is required?
The track should also be clear.
No, sir. Actually, CPR up and WLR also require up.
No, we are going, when it is going to be unlocked, that we will see later. First, what is the conditions required for unlocking? We are seeing it. So for unlocking this one, for sending the power, what is the conditions required? First, that should not be engaged in any of the signal route or overlap. That means all the signals associated with that point, those ASRs or OVSRs should be in up condition. And what is the one more condition required?
This track should be clear.
Concentric circuit is clear.
Whatever the point zone track circuit is there, that track circuit should be clear for normal operation. So here we got two types of operation. In the normal operation, when the concerned point zone track circuit is in up condition, and in the emergency operation, even if the track circuit is in fail condition also, we can still operate the point. That is emergency operation of the point. Okay, now
Crank
you
handle
should,
should be in.
what is that?
Crank
Yes,
handle
guys.
should be in.
Yeah, so since the point can be operated in the mechanical means also, while operating one means, we are not permitting the other means to operate. So when I'm going to send the power, I ensure that that concerned crank handle for that particular point is in locked condition. Yes, if these three conditions are satisfied, can we operate the point?
Yes.
Are they sufficient, or still some more conditions are required?
Electrically free.
Electrical fee, you mean?
Concerned WLR should be picked up.
No, for picking up WLR only we are seeing it. That means I don't know what is the practice in your zone. Normally WLR is drop condition. So when particular conditions are satisfied, we are going to pick up. Once WLR is through that, we are going to send the power.
Authorized operation, SMS should be there.
Yes, Mr. Pramod Kumar.
UCR should be
Authorized
pick up.
operation, station master key, SMS should be there.
Yes, okay. It should be an authorized operation. Very good point. So how we are going to ensure that it is an authorized operation?
SM key.
SMCR.
So are you using SM key in WLR circuit? Are you ensuring that one? Though it is not used directly, it is indirectly proved, because there we are going to prove either NCR or RCR. So in the NCR or RCR, we got the SMCR contact. Okay, we are going to prove that is an authorized operation by SM. SMCR is up. And one more condition is there. What is that condition? So all these conditions so far, what we have discussed are normally satisfied. You assume that your ad is free and no signal has been cleared. All routes are free. Then the points that signals associated with that point ASRs are in up condition. The point zone track circuits are in up condition. The crank handles are in and locked condition. And the SM key is also in. All these conditions are normally satisfied. Will the point automatically operate itself? Because the conditions are satisfied.
We have to operate.
Operate the point.
Yes. The SM should turn the knob from normal to reverse or reverse to normal. So how do you express this in the form of circuitry? Okay, this we will see more detail in the point operation. There we are going to see that NCR is up and NWKR is down, or RCR is up and RWKR is down. So that indicates the knob has been turned from one position to other position. So with these conditions, we are going to initiate the point operation. So here in the route setting type, all the points that are falling in the route, they should be operated by the operator individually, and then only the signal is taken off. Whereas, as we have seen in the route setting type, once he identifies the route. So how he is going to identify the route? By pressing the concerned signal button with that concerned route button. So for this combination, for a particular route button and a signal button combination, we are going to pick up one NRR. So there are as many NRRs as there are number of routes for a particular signal. So this NRR is going to define the route. So we know what points are falling in the route. And if the point position also, we are knowing the current point position. If the point is in out of favorable condition than the required condition, we are going to initiate its operation. So here in route setting type, if once the entrance button and the exit button, that means the signal button and the route button, if these two are pressed, whatever the points that are falling in the en route, if the points are in not favorable position, they are going to operate automatically for the favorable condition of the route. Is it clear? Hello?
Yes.
Yes, sir.
Yes, sir. Yes, sir.
Right. So this non-route setting type is generally used in the smaller yards and wayside stations. And here, this route setting type we are using in the bigger yards or major yards. Here, the route buttons are not compulsory. So if the route buttons are not compulsory, how he is going to identify the route? He need not have any route button at all. Suppose he is going to set the route automatically by operating the points individually and then turn the signal knob to reverse. So these are not compulsory. And here the route buttons are compulsory. We need to identify a particular route. So for particular combination of one signal with a particular route, we are going to pick up one delay so that the route is being identified. And we are not saying it is not compulsory. Then in what cases it is required? In the panel interlocking, we are saying that route buttons are optional. We need not provide. So if you need not provide, we are going to usually operate the point to the desired condition and then turn the signal knob to reverse. The signal is going to be taken off. Under what conditions these route buttons are required? Yes, anyone?
If there are so many routes.
Yeah, generally a signal will have more than one route. No? It will have more than one route it will be having. So if suppose signal S is there, it is having say 4 routes. If I want to set for second route, I am going to set the points in that route which are favorable in condition for that particular route. I am going to operate all the points to the desired condition of the route, and then I am going to take off the signal. And where is the question of route buttons? So if I am going to incorporate the route setting feature, that means then I'm going to press the signal button on that particular route button. If I'm going to give this facility for panel interlocking also, then the route buttons are compulsory. Otherwise, they is not required. So here, as per the latest policy of RDSO, even for panel interlocking also, we need to give the route setting type feature. So if I am going to give the route setting type feature, even for panel interlocking, then what is the differences between the panel interlocking and the relay interlocking, the non-route setting type and route setting type? There are other differences between the two. That means sectional route release and all are not provided in the panel interlocking, whereas sectional route release and all should be available. Likewise, the emergency operation of point not available in the panel interlocking, and it should be provided in the route relay interlocking and all. So generally, this panel interlocking is provided in smaller yards and RRI in the major yards. The route buttons are not compulsory in the panel interlocking, whereas they are compulsory in the route relay interlocking. And CLS is an optional, whereas it is compulsory in route relay interlocking. And we got the feature of sectional route release. So what do you understand by sectional route release? Can someone please tell me?
Yes. In sectional route release, we release route in parts.
Yes.
Route is divided into number of subroutes.
Yes. So here we are going to divide. So here the entire route we are going to divide into some subparts, and when we are going to release that particular subpart,
when the train has has moved away ahead of that route section.
When the train has cleared that route, it has already passed that route, we are going to make that points free. So how is it being achieved? How do we know whether the train has passed or not?
By the help of UR1 and UR2 circuits.
Yes, yes. So different zones have got different practices. The names of relays may be different, but the logic will be same. We will be using TLSR or TRSRs as in the South Central practice. So once that consent, what is the normal position of the TLSR or TRSR?
Pickup.
Yeah, normally pickup. So when that consent, are you able to see the screen?
Now disappeared, sir.
So what are you seeing right now in the screen?
Catalog दिख रहा है.
Reset websites.
Is it okay? Then we will go for that. Just a minute. It's not getting there. Are you able to see it?
No, it's blank yet.
No, sir.
Blank, sir.
Are you able to see the screen or not?
No,
Not
it is blank.
Page is blank, sir.
Not.
Yes, sir. Now come.
So we are seeing about the sectional route release. In the sectional route release, the entire route is divided into some certain sections. Suppose this is the total route. We are going to divide into some sections of this route. So this section will be controlled by a particular relay. Say the first section will be controlled by the ASR, and the subsequent sections, say if it is for light side movement, TLSR or TRSR, depending upon the direction of the movement. So likewise, the next section will be controlled by the previous TLSR or TRSR, and subsequently like that. So when the particular signal is taken off, all this entire route will be in locked condition. When the train has cleared a particular subsection, those points will be released. That means release means those points can be operated for other movements in the yard. Normally, until the train passes the entire route, if we are keeping only one ASR, we are not going to release the route. So we are going to prove this backlog tracks in the ASR circuit. Until that backlog tracks are in up condition, ASR will not pick up. So what do you understand by backlog tracks? Yes, can someone please tell me?
The circuits other than platform platform.
Okay, from where to where that forms the backlog tracks?
It starts from example home to that last project.
Yes. So all the track circuits that are falling from the foot of the signal to the last point that is encountered in the route. So all the track circuits forms the backlocking tracks. So why I am interested in only backlocking tracks? Why berthing track I am not interested? I am going to pick up the ASR only when all the backlog tracks are in up condition. So why only backlog tracks? Why not all the controlling tracks?
Backlog tracks has the capacity to make the route change.
Yes. So once the train has passed the last point in the route, there is nothing further to change it. We are not going to change the route further. So when we are going to consider all the track circuits from the foot of the signal up to the last point zone track circuit in the route. Once they are cleared only, we are going to pick up the ASR. We are going to release the route. Because this ASR we are using in the point lock circuit, in WLR circuit. If ASR is in up condition only, I can send the power, I can pick up the WLR for operating the point. Otherwise, it is not possible to operate the point. So here in the sectional route release, once that particular section has been cleared by the train, we are going to see that the particular points in that section can be operated. Otherwise, if the sectional route release is not provided, we need to wait for the train to entirely complete the path. It has to complete the entire route. Then only we are going to put the point. Is it clear? Hello?
Yes, sir.
Yes.
Right. So here the track circuiting is done from home to home, whereas in the route relay interlocking, we are supposed to do between distant to distant, between the outermost signals. But in most of the cases, only from home to home we are going to do. We are going to provide only the calling on track before the home. So the entire yard will be track circuited. Here in the panel interlocking, we got only 2 positions for the point. So how we are going to define the point position? The knob is there, either the knob is in normal condition, or if you are going to turn for reverse, the point knob is in reverse condition, either normal or reverse. So this condition we are going to convert this into a position or status of a relay. That means this position of the point knob, we are going to quantify by the status of relay. If the knob is in normal condition, I am going to correspondingly pick up a relay called NCR, which is corresponding to the position of the knob. And likewise, when I turn the knob to reverse, I'm going to keep one more relay RCR. So if the knob is in reverse, I'm going to pick up the RCR. So here in the panel interlocking, the emergency operation of the point is not compulsory. So what do you understand by this?
Track circuit fail होने की condition में sir.
Yes.
Emergency point operation.
Yes. So if the track circuit is in failed condition, we are not going to permit the operation of the point. Whereas in the emergency operation of the point, even if the track circuit is down also, we are going to permit its operation. So these are the few differences between the panel interlocking and the root relay interlocking. And as I said before, as per the recent specification, the PA stations also should be provided with the root setting type feature. So when you provide with the root setting type feature, only a minor differences like sectional root release, emergency point operation will not be available in the PA stations, whereas those features will be available in the RRI stations. And we are supposed to use the dominant type panel for all the new installations, but there may be general practice which where conventional panels are still being used. But RDSO recommends to use the domino type panel with self-restoring buttons and all. So what is the advantage of using this type of panel over the conventional panel? Can someone please tell me?
This modification, it helps in easy modification on panel.
Yes, very good. You can easily modify the alterations or modifications in the yard. So here in the panel, if the knob is there, the signal knob is there, once the train has cleared the route, will the route release automatically without normalizing the knob? The train has passed the last point on track circuit. So to pick up the ASR, whether we need the condition of the knob normal or not?
Point that not have knob has to be normalized.
Yes, normal contact is required. When we are using a knob type panel, the SM is supposed to normalize the signal knob, then only we are going to release the route. But whereas when you are using all self-restoring type buttons, once he presses the button and leave it off, it is going to come back to its original position, both the signal button and the root button. So once the train has cleared the last track circuit of the point zone, the last point that is falling in the route, the ASR is going to pick up automatically. He need not do any extra operation. What is the extra operation he need to do in panel interlocking? Yes. In panel interlocking, our knobs are provided. We are supposed to normalize the knob for picking up the ASR or for releasing the route. Whereas when you use the domino type panel with self-restoring buttons, so no extra operation is required. Once the train completely passes over that route, and once it has cleared the last point on track circuit in the route is going to be released automatically if other conditions are satisfied. So on the panel, we are supposed to provide, as per the specification, various indications and self-restoring buttons of various functions. These functions, points, signals, track circuits are represented geographically on the panel. So corresponding to their layout on the outside yard, we are going to give a panel. So on that panel, we are going to provide all these functions. So the provision of track circuits with the demarcation. So you are going to differentiate between one track circuit to another track circuit by providing with the different colors. We are going to provide on the panel. And in PI, the points are provided with 2 position switches and RRI with 3 position switches. So what is the purpose of providing the third position? NCR, normal, or the central, on the reverse. So if the point, suppose if the point is physically in normal position, so what position of the knob corresponds to this normal position in the point, in the field? What is the third position of the point? Either it will be
to normal and it is locked in the root.
yes, when the point is in normal. So we are going to see that for automatic operation of the point, we need the keep the point knob in the central position. Then only the automatic operation of the point is permitted. So in RRI, we are going to see the point is having the three positions. Either it can be the central position, or it can be in the normal, or it can be in the reverse. So in the panel interlocking, we got only two positions corresponding to the position of the knob. Either it can be in the normal or reverse. We don't have the automatic operation of the point here. So all other switches, we are having the two position switches, either normal or the reverse. In RRI, all routes with the different overlaps will have a separate route buttons. So if you want to take the route for reception on the loop line, or for with random setting, or you want to take for a loop through with the different overlap, you got separate route buttons to differentiate the two. So here we are going to use metal to carbon contacts. The color light signals are provided. So in the diode is track circuited in the PI between the home to home, whereas in the RRI we are supposed to track circuit between the outermost signals. And crank handles, the level crossings are interlocked through corresponding relays. We are normally using the PVC 16 strand 0.02 mm flexi wire for relay wiring. So these are some of the features in the specification. And all the indications. So what are the various indications we are going to provide on the panel? Please tell me. So we are going to provide the indications on the panel. What are the various indications we are going to provide? Or what functions we are going to provide?
Signal points track, sir.
Yes. So for all these signaling base, the signals, the points, the track circuits, and various other functions, yes, the block instrument or the LC gate position on the signing key.
Yeah, sir.
So whether the SM key is in or out. So all these various indications we are going to provide. These indications are provided with 12 volt 1.2 watt LEDs on the panel. And we are going to give a stabilizer supply for signals and unstabilized supply for AC track circuits. So why we are giving a stabilized supply for signals and unstabilized supply for track circuits? If available, nothing wrong in giving the stabilized supply for both. But why the stabilized supply is insisted for signals? If we are not going to provide a stabilized supply for signals, what can happen?
Signal will go black.
There is a possibility of flyback of signal.
Yes, it can. No, why it go to flyback? Yeah, if there is the voltage, it can be. If it is not stabilized voltage, yes, it is not a stabilized voltage. If there is fluctuations or if the power has gone and come off, if there is no backup, it is going to give a blank signal in between. So why we are going to give unstable supply for track circuit? Yes, tell me.
Power fluctuation may be there, sir.
Yes, toward this power fluctuations and all, but these fluctuations can be permitted for track circuit. Why they can be permitted for track circuit?
Battery backup is available.
बैटरी भी लगाते हैं सर, बैकअप रहता है.
Extra battery available na track circuit.
It takes care of the fluctuations. So we insist
को
for,
सर बैटरी से देखते हैं.
yes. So we insist for stabilized supply for the signals. So stabilized supply means we got many sources of supplies. Either we can have from the AT, or we can have from the local supply, or we can have from the genset. So which one you would prefer to have as the main source of supply?
AT.
Why do you prefer AT as the main source of supply?
It is mostly available.
Yes, it is more reliable. Normally we are going to take AT as the main source of supply. But where in major RRIs, where the local supply is more stable, we are going to prefer the local supply as the main source of supply. Why?
Yes.
Why we are going to prefer the local supply as the main source? Because we are saying it is more reliable. there are no power cuts in that major RRI. Why not the AT in such a scenario? It is also more stable one only. Sometimes we may be taking some power blocks and all that interruption may be there. So in a major RRI, where the local supply is stable and available for most of the time, we are going to keep the local supply as the main source of supply and AT as the standby. And genset, of course, we should have as the standby. If all modes are fail, then we need to give the supply for the station through genset. So what is the first thing you are going to ensure while supplying the supply through genset? Suppose that station load is say some 15 kVA. If I am going to provide 10 kVA genset, will it work? So what is the first point you need to consider? You need to see for which station you are going to provide and what is its approximation load. Whether my genset will be capable of taking the load or not. So for that, in the S9 subject, you will be learning in the further classes of this course. You will be calculating the power requirement, the load of a station. So here we are going to provide the panel indications with the 12 volts or 24 volts, the DC. And we have got different source of power supplies where the AT source is available. Through AT, we are going to provide that as the main source of supply. So if the failure is there, the automatic switchover will be there from the up AT to down AT and then to the local. So here, where only one AT is available in a single line section, so we are going to provide one genset as a standby. If other modes of supply fails, like AT and the local, we are going for the alternate for giving the supply through genset. So in big yards, DC sets of aggregate capacities will be installed in addition to the AT supply. So these are the points we are going to ensure which has to comply the RDSO specification. The condition of block instruments on the panel. In case of cancellation of a signal, certain time delay is required to be given for releasing the route, provided the train has stopped in day of the signal. So why we need to give? Suppose the signal is there, we are going to clear for a particular route that signal. So should I not cancel that signal immediately? Suppose the train is coming here.
Due to safety, sir, after 2 minutes, it is released.
Yes. Suppose if the train is say at a distance of say some 100 meters is there, it is coming with some full speed of the section. So if I immediately throw back the signal and cancel the signal and alter the route, what will happen? Even if that information of change of the signal is known to the loco pilot also, it is of no use to him. He cannot control his loco to come and stand at the foot of the signal. So when he is coming to overshoot, there is a possibility he will overshoot the signal. So what should be the minimum distance at which I can give so that he can comfortably stop his train? The signal information, if I give from what distance, so that he can comfortably control his train.
1 kilometer.
Signal about that, sir.
What is it?
It is 1 kilometer, sir.
So suppose a stop signal is there, if this information is given about the aspect of the signal, about the normal braking distance, then if he knows the aspect of the signal, he can start controlling the train. So that if he applies the normal brakes, it will stop at the foot of the signal. In case this distance is not available, or suppose if I provide a track circuit, this track circuit is in occupied condition, that means the train is within this track, then I am going to give you a condition that I cannot cancel the signal immediately. I cannot alter the route immediately. Only after some fixed time delay only it can be done. So we call this track as the approach track. If the approach track is in occupied condition, or in some cases we don't have the approach track, we got only a net approach locking where a fixed time delay will be given. After that fixed time delay only, the route alteration is permitted. Suppose if this approach track is in free condition, That means there is no train in the approach. Can we cancel the signal immediately?
No, sir.
Yes.
Time delay required.
Yes. No, not required. Why?
Signal
Because
cannot be.
in the approach, there is no train. If the approach track is available, that approach track is in up condition. There is no train in the approach of that signal. Then we can cancel the signal immediately without any time delay. If approach track is available and if it is in occupied condition, then we are going to give a certain time delay. Or if there is no approach track at all, the sufficient length of approach track is not available, we are going to give a time delay that we call as a dead approach locking. We are going to give a fixed time delay. Only after that time delay, we are going to alter the route. Is it clear?
Yes, sir.
Yes, sir.
The tea break is going to expire.
What is it?
Yes, sir.
Tea break.
Repeat. Okay.
So it was tea break from 3:30 to 3:45.
No, your voice is not clear. Do you want me to repeat that one?
No,
Tea
sir.
break.
Yeah.
I want to say that that it was tea break
One
from
tea break,
3:30 to 3:45.
What is it? 3:45.
There is tea break for 15 minutes, sir.
15:45, sir.
Tea break because the class has started lately, so I have cut that one. I will leave by 4:30 then.
Yeah, continue, sir.
You are supposed to go. You want to have a break? Okay, please have 5 minutes break and come back then. 5 minutes break.
Yes, sir. Yes, thank you.
Right.
Okay, thank you, sir.
Right. Shall we start the session?
Yes, sir.
Shall we start the session?
Yes, start, sir.
Right.
Yes, sir.
Right.
Yes, sir.
So here we are ensuring that for every operation, the SM key is in and lock the panel. So we are proving this contact that SM key is available in all the circuits to ensure that all the operations that are performed are authorized operation. Those operations are performed with the willful knowledge of the operator. So here in the control panel, we are providing the signals with the rotary type switches, or in some panels, there will be only buttons, both for signal and route. All buttons are available. In some panels, the switches are available for the signals and buttons for the routes. So near to the geographical location with indications. So various indications of the signals we are providing, whether the signal is at off condition or on condition, what is the aspect it is displaying. All this we are going to provide on the control panel. So all points also we are going to provide either the 2 position or 3 position it can have. For either for PI, we are going to have a 2 position knob. For RRI, we are having a 3 position knob for the point. And we need to provide the indication of the point, whether the point is in normal or reverse, or it is free, or it is in locked condition, we need to provide it. And we are going to provide indication for the track circuits. And to differentiate between the track circuits, we are going to provide the 2 different track circuits nearby with the different colors. And we have got controls for sidings and all, the controls for siding, level crossing, and crank handles. So these are provided with the buttons or switches and the various indications on the panel. So when the route is in set and locked conditions, the white strip of light indication we are going to give it. So now what do you understand by mean the route is set and locked? The route is in locked condition means what do you understand?
Lock means we are not able to alter it.
It should not alter, sir.
What should not alter?
Sir, points are set and locked.
Yes.
Properly.
The
Route is locked.
Route is locked, sir. Yes.
Route is nothing but route is defined by the point position only. If the point position changes, the route is going to change. So what are the points that are falling in the entire path? Those point positions should not be changed. Should not be changed means how we are going to ensure that the point position
The short drop, sir.
Yeah, that is technically a drop. So we are going to see that the point cannot be operated either electrically or the point cannot be operated in a mechanical means also. So we are ensuring that that corresponding crank handle of the point is in locked condition and that WLR is in the normal state of down. So if the concerned ASR of a particular signal associated with that point is dropped, that means it is in locked condition, the WLR will be in locked condition only, it cannot be picked up. So if WLR is in locked condition, we are ensuring that the power doesn't goes to the point. So basically, when you are locking the route, you are indirectly cutting all the power supply for the point motors in the route. Even if you try to operate, if you try to change it, when the route is in locked condition, it will not operate. So when the route is in certain locked condition, we are giving a different indication on the panel that white strip of light will be appearing. So what will be there if the route is in normal position, if nothing is initiated? Hello? Are you getting my voice?
Yes, sir.
So what indication you get there? When the route is in normal condition.
In normal condition, there will not be any.
Green.
Green. No indication. We are not going to give any indication for the when the route is in normal state. If it is initiated and locked, we are going to give the white strip of light. Yes. So when the route is being passed, that means when the train is passing over that route. So how do you give the indication? That concerned tracks and routes where the train is passing, that is going to turn to red color. So the red indication can be there for the occupancy of the track or the failure of the track. So we are going to give these indications on the panel. So control for emergency signal and the route cancellation, emergency point operation with counters. So these facilities we are going to provide on the panel. For any cancellations, we are going to increment the counters, which are non-resetable counters. And SM key is provided to lock the panel to prevent unauthorized operation. So when SM has locked the key and he has taken the key and gone, so we are not permitting any operation of the panel. What is the operation that is permitted even if SM goes away?
Automatic to send signal to danger.
Signal danger, sir.
Yes. So we are going to give only that operation. Other than that, we are not going to permit any other operation. And whatever the SM has operated over that panel, that remains in the same status. We are not going to alter it. This we will be seeing in the circuitry how this is being achieved. So in a control panel, there is no physical interlocking between various switches and buttons, whereas in the mechanical lever frames, we got direct interlocking between the levers through the locking tray and all. So here in the relay interlocking, we are achieving the same interlocking by means of relays. Here the relay status is going to tell us different conditions of various switches or buttons or different conditions of the signaling gear. This different condition of signaling gear we are quantifying by the pickup or drop status of the relay. If a particular gear is in particular position, a particular relay will be in up condition. When I change that gear to the other condition, this relay is going to change its position. Like that, we are going to have the correspondence and we are going to achieve the interlocking by means of these relays. So in the conventional panel, we got only a single plate, non-domino type. It is the conventional panel, a single large plate will be there. And we are going to fix the different signaling switches and buttons and indications over this one. If any alterations are there, then we need to change the entire panel. So to overcome this one, we got the domino type panel. So here the panel is divided into small rectangular plates of 63 by 38 or 54 by 34 frames. We are going to assemble this one, and these switches or buttons and indications, those are fitted in the dominoes itself, and wirings are terminated with male and female sockets. So here the alterations can be done easily. Not only this one, if you see the failures, the knob failures will be comparatively more than the buttons what we are using in the domino type panel. So this is how a single plate non-domino panel looks like, a single plate. And this is the domino type plate. So we can see some rectangular assemblies. With this only, this entire panel is made. So on the dominoes, we are going to give the provision for buttons, the signals with the various indications and all. So here these are the advantages. The push button operation for each function, we are going to provide all the buttons are self-restoring type. So when the train has passed over the entire route, the SM need not do the extra operation of normalizing the knob or releasing the route. The route is going to release automatically because buttons are self-restoring type. The route get released as the train clears the route, no extra operation is required. But whereas, what is the extra operation required when I am using the knobs? Yes, please tell me. Hello, are you getting me?
Yes.
What is the extra operation when I am using knobs? What is the extra operation required?
The knobs have to be reversed.
Not reversed, they have to be normalized. So we are using the knob normal contact in the ASR circuit to pick up the ASR. So once the route is in locked condition, ASR will be dropped. To pick up it again I require the knob normal contact. So here in the operating panel, it is compact when I am using the domino type panel, and the alterations are easy to make for adding or deletion of this one. And this I got the spring-loaded silver tip contacts, so where the failures are comparatively less than the knob failures of the signal knobs and all. So if required, depending upon the size of installation, we can have a separate control panel and a different panel for indication. We can have two separate panels. So here, these are the various indications that we are going to provide on the panel. The track circuit indications. So what are the different track circuit indications we are going to provide? Yes, can someone please tell me?
Sir, track clear, track locked, track occupied.
Yes. So when the track failed also, we are going to give it in the track occupied only. If the track circuit is
failed means track occupied.
Yes. If it is in failed condition or occupied condition, we are going to give the red indication. Or if it is in the route locked condition, we are going to give the white indication. And in the normal course, when nothing has been initiated, no indication is given. Likewise, we are going to give the point indication. So what are the different point indications we are going to give? Whether the point is in normal position or in the reverse position. Unlike that, we are going to give for the signal indications. So what are the different signal indications we are going to give? Whether the signal is taken off or is in the normal condition. If it is taken off, what is its condition? Whether it is in yellow or double yellow or green. So all the aspect of the signal, these indications are given in the panel. And some miscellaneous indications like the closure of the LCs and all we are going to provide on the panel. So this is about the track circuit. If it is clear, no indication. If it is set and locked, white indication. If it is occupied or failed, red indication. So if the track circuit is, if nothing has been there, no indication will be there. So if it is being initiated, it is set for a route and locked condition, we are going to go by a white strip of light. Or if it is in failed or occupied condition, we are going to give by a means of red indication. And this panel indication, we got two methods where the near knobs, we are going to provide the indication whether it is in the normal position or in the reverse position, it is free or it is in the locked condition. So we are going to provide at the position of the point knob or directly on the layout, we can give it. So this is the point knob position. Depending on the position, we are going to give these indications. Likewise, on the yard itself, on the yard layout itself, on the control panel, we can have a indication. So if the point is in normal, we are going to let these two indicating the normal position. If it is in reverse, we are going to give this indication. So likewise, we are going to give the various indications when the track is occupied or it is in free condition. We are going to give various indications on the panel. For signals, so if it is at stop, red indication, if it is off, we are going to give either LR, WL or green, depending on the aspect that is being displayed at the site. And for calling on and all, we don't give any aspect, any light of the signal. If in the normal condition, if it is cleared, we are going to give the indication. So for the shunt also, where this is a separate post, 2 white lights horizontal, or if it is taken off with a slanting lights glowing, we are going to give it. So when it is on a stop signal, normally no indication is given. When it is taken off only, we are going to give the white lights, 2 white lights in a slanting position. So these are the various indications that we are going to give on the panel. And we are going to give whether the signal is cleared with the route or not. So all this will be displayed on the control panel. Different aspect of the signals. And whether the LC gate is in open condition or in the closed condition, whether the SM key is in or SM key is taken out. All these indications we are supposed to give on the panel as per the specification. And we got some buttons, the common buttons. So where all buttons are available on the panel for signals, for routes, for all functions. When you got the buttons, we got some common buttons. So what does this common button indicates? What does James here indicate?
Indicates signal buttons.
Cancellation.
Yes, whether all the signal buttons are normal, or whether all route buttons are normal, or whether all point buttons are normal. These are the common thing. So it will, this corresponding relays will be in pickup condition if all that concerned function buttons are in normal state. So this, we are going to give different functions. We are going to differentiate the buttons by various colors. So as per the SCM and the color practice in practice, what we are going to use. There may be slight variation, but depending upon the general practice, as per the SCM, this is the color prescribed for the concerned button, and there may be variation in the color code that is being practiced. So we got the calling on button, and what is the COGGM? Common calling on button.
Calling on.
Yes. So when you have got more than one calling on in a yard, so normally what will be happening? We sometimes provide a common button. So when you press the signal button along with that common button for calling on button, then only the concerned signals calling on will be actuated. Or in some practice, we got a separate buttons for the calling on, separate knob for the calling on signal also. And we got the common buttons. Yes, this is the common buttons I am telling for normal operation of the point and all. So we got for normal operation for reverse or for normal. So when you press that concerned point button along with the common button for normal, so this point is going to be thrown for normal position. Likewise, when this point button is pressed along with the common button for reverse, the point will be operated for reverse. So these are the different buttons that are available on the panel and their color code. I think during the circuitry part of discussion, we can have what each buttons and how the corresponding relays will be changing the state that we can see in the circuitry part. And various indications we have seen about the point, crank handles, and the track circuit. So this is the nomenclature. We are going to use this one for signal as GN, for route as UN, for calling on COGGN, for point WN button. So this is the nomenclature. Maybe it's slightly something different from your zone, but mostly it will be the same. Slot transmit, slot receive. We'll be seeing in the circuitry part where this corresponding relay status and all we are using in the circuitries. Now we see the various sequence of operations on the panel that has to be performed for clearing the signal. So setting the route, we are going to set the route. After setting the route, that means after setting the points to desired position, we are going to lock the route. So lock the route means once the checking is complete, yes, I have checked all the points that are in the correct position, then I am going to fix that. I am going to lock that. I am not going to change that further anymore. I am going to cut off the power supply for all the points in that route so that the route is in locked condition. Once the route is in locked condition, I can clear the signal given that other conditions are satisfied. So after clearing the signal, once the train passes that route, I'm going to release that route so that that points can be operated further for other operations. So we will see the operations, how they are going to differ in panel interlocking and the route relay interlocking. In the panel interlocking, as we have discussed earlier, the manual operation of the points should be done. What are the points that are falling in the route? All these points should be individually operated. All the points in the route overlap in isolation. But whereas in the route setting type, once I press the two buttons, the entrance button or the exit button or the signal button and the route button, the points that are falling are going to set to their favorable position. So if the point is not already in favorable position, it will be operated. When the points are correctly set and locked, we get the indication. So this indication is given by these relays, NWKR and RWKR. So the operator knows what is the position of the point currently in the field, whether it is in normal or reverse position. So it is to note that before a point is operated, all conditions like SM key is in, the point is free from any of the route, the crank handles of the concerned point are in condition, and the track circuit is clear. All this we are going to check during the point operation. So once we are going to check the route and all, then we are going to finally clear the signal by reversing the signal knob. So after ensuring that all points are correctly set and locked, then we are going to reverse the signal knob. So once depending upon the signal knob, we got a relay called RR. Wherever the panel is provided with knob type, we got the position of the knob indicated by a status of relay called RR. If the knob is in normal condition, the RR is in drop. If I'm going to reverse the signal knob, that concerned RR is going to pick up. So this, the first stage, we are going to prove in this one that the conflicting signals RRs are in down condition. So as I said earlier, this being a vital condition. So what is the vital condition here? The conflicting things should not take place at the same time. So the conflicting signals should not be taken off at the same time. This condition is proved in thrice. It's proved in 3 circuits. Once in the RR stage, and the UCR stage, and finally in the HR stage. We are going to prove that the conflicting events doesn't take place simultaneously. So once the points are being set, we are going to verify that one, whether the points have been set properly or not, or whether the indication is available or not. So once after ensuring that point indications, all the point indications are available, we are going to pick up the UCR. We are going to check the route. So in the route, we are ensuring only the point position. Are we ensuring the track circuit position in the UCR of that concerned route? Hello, are you getting me?
No, sir.
Yes. So this track circuit position only in HR we are going to ensure whether that all the controlling tracks are in up or not. In the UCR, we are going to check the point position of the route, whether the points in the route are in correct position or not. So once this checking is done, then if it is found correct, that means the UCR has picked up, then I am going to not change the route further. So this I am doing by using the ASR relay. Once I pick up the UCR, I am going to drop the ASR. This ASR is used in WLRs, in the point lock circuits. Once the ASR drops, So all the points associated with that signal cannot be operated. Those WLRs will be in drop condition. So here, once the checking is complete, I'm going to lock the route. That means I'm not going to change the route further. That means I'm going to cut off the power supply for all the point motors that are in the route once UCR picks up. So to achieve this one, I am using this UCR back contact in the ASR circuit. Once the UCR picks up, the route checking is complete. I am going to drop the ASR. That means that concerned route is in locked condition. So here, as and when the route checking relay UCR is energized, the concerned signal ASRs along with the overlap control relays OVSRs will drop. And thereby all the points in the route overlap and isolation are locked. So the ASR dropping ensures WLRs remain in the drop condition and thereby locks the points. So in the non-route setting type, once the route has been verified and the route has been locked, then when other conditions are fulfilled, we are going to take up the signal. We are going to pick up the HR. So if I am going to pick up the HR, what does it mean? In one line, what does it indicates if the HR of a signal is in up condition? What does it indicates?
Means the route is clear to the next signal.
Yes, that means it has fulfilled all the conditions for interlocking. All the essentials of interlocking has been fulfilled. I can give the off aspect. What is that? Yeah, proceedings. I can give off aspect for the signal. So if HR is in up condition, I can give off aspect for that signal. And in the off aspect also, which off aspect to be given? Either the yellow or double yellow or green, it is going to depend further on the ahead signal aspect. So basically HR is an up condition says the signal has satisfied all the conditions, all the essentials of interlocking. Off aspect can be given for that particular signal. So HR, we are going to incorporate some other features like one signal, one train movement, and the head signal is not blank. We are going to see all the conditions. So here, once UCR picks up, ASR drops, that means the route has been verified, the route has been locked, and the route, then the signal is taken off, provided all other conditions required for clearing the signal are fulfilled. These conditions we are going to see in the further circuitry part. So the signal off indication will appear on the panel. Once the signal has been taken off, we are going to give that indication for the operator. So if you see, this follows the sequence of operation. So we are first ensuring that SMCR is up. That means all the operations performed on the panel are authorized operations. Then the manual operation of the point should be done by the operator. So the operations of the points should be done individually by the operator. The point should operate. Once the point operates, we get the indication of the point, NWKR or RWKR. Then we are going to initiate the signal. We are going to turn the signal. Before that, we are going to check whether all the points have been correctly set for that route or not. We are going to pick up the UCR. In this UCR, we are going to see that the conflicting signals UCRs are in down condition. In the RR also, we are going to see that the conflicting signal knobs are in normal position. And finally, in the ASR circuit, where we are going to lock the route, we are ensuring that once the ASR drops, or the WLRs of the points corresponding to that one are in down condition so that it cannot be operated. So after ensuring certain other conditions are being satisfied, we are going to take off the HR. We are going to pick up the HR. So if you see the same operations on a route setting type. So the route setting type, we need to first identify the route what we are going to set. Why we need to identify the route what we are going to set? What is the requirement for me to identify the route that I'm going to set in route setting type panel? Hello, are you able to get me?
Yes.
Suppose there are
Because this point, button position is not giving any information regarding the root circuit.
yes. That means I need to identify which point I need to initiate for operation. Suppose in the yard there are n routes, 300 routes or 400 routes. This particular routes say 1, 3, 4. These routes are associated with some point. Say a point number 1 it is being associated. Say we will take for example 4 routes. Route number 1, route number 3, route 4, and route 5 are associated with this point. Now, these particular routes, route number 1 and 4 may require this particular point in normal, and route number 3 and route number 5 may require the same point in reverse. So first I am going to list out all the points, P1, P2, all the points in the yard. I am going to map how many routes are associated with that point. So I am going to see whether this particular route is initiated or not. How do I know whether route 1 is initiated or route 3 is initiated? How do I know that? So for that I am going to keep a relay, NRR relay. If that particular route is initiated, that particular NRR is going to pick up. Now, if these routes 1 and 4 require the point in normal position, if the point right now is in reverse position, then I need to initiate its operation. So if that particular route, if the first route NRR has picked up, or if the fourth route NRR has picked up, that means the NRR of the first route or NRR of the fourth route has picked up, I am going to initiate the point for normal operation. The point is required in normal. So if the point already is in normal, do we need to initiate its operation? If it is already in favorable condition? No. So I'm going to see that NWKR is not available. This particular route is initiated. It requires the point in normal. It is not already in normal. If it is already in normal, I need not initiate because it is in favorable position for me. So when I'm initiating these routes for normal, I am going to see that the routes which require the same point in reverse are not initiated, because I cannot operate or initiate the point operation for both normal and reverse at the same time. So I'm going to see here that the routes 3 and 5 are not initiated. Only the route 1 and 4, any one of these route has been initiated, and the point is not already in favorable condition. So with these conditions, I am going to initiate the operation of the point if it is falling in the route and if it is in unfavorable position. So for this, I need to do first, what I need to do? I need to do the route selection. I need to identify the route. So for this purpose, I got a separate signal button. When it is pressed with the combination of a particular route button, I am going to pick up one relay, NRR relay. So in the NRR relay, in the first stage itself, I am going to check that the routes which are conflicting to this particular route are not initiated. So those NRRs, I am going to see that they are in the drop condition. So once the route setting has been done, the picking up of NRR decides the point position for a given signal route. So for a particular route, we are in a position to identify what are the points associated with that route. And we are going to see if the point is already favorable condition, nothing operation to be done, we are ignoring it. If the point is in the route and if it is an unfavorable position, we are going to initiate its operation. So the picked up NRR contacts are used in the required point control circuits to operate them to the correct position for the signal route in case those points are not already in favorable condition. So if you see the sequence of operation, once the signal button and the concerned route button is pressed in route setting type, the points which are falling in the route are going to automatically operate. So once the point operation is complete, we need to check whether all the points have properly operated and indication is available or not. So this we are going to do by the concerned UCR relay, whether all the point indications are available or not. So once the point of indications are available and route checking has been complete, we are not going to change that route further, or we are going to log that route. So how we are going to log that route? We are using the UCR back contact in the ASR circuit. Once UCR picks up, which means the route is checked, we are going to drop the ASR, which means the route is in locked condition. So then the signal is taken off immediately, provided all other conditions for clearing the signal are available. So once these operations have been complete, we are going to give off aspect for the signal. So if you see the operation in root setting type panel, here the roots are set by operating individual points. If you press the signal button on the root button, or where knob is available, if you turn the signal knob and press the root button, it is going to pick up the NRR, which is going to identify the root what we are interested in. So in the NRR circuit, for the first time we are going to prove that the conflicting NRRs are in drop condition. So here the operation of the points, if they are falling in the root and if they are in unfavorable position for that root, they are going to be operated automatically. So once the point operation has been complete, the point has completely operated or not, whether the indication is available or not, that we are going to check through this UCR relay. Once the UCR picks up, once the root checking has been complete, we are not going to change the root further. That means we are locking the root. So we are dropping the ASR. So we are using the UCR back contact in the ASR. Once it picks up, it is going to drop the ASR. So once ASR drops, when other conditions are fulfilled, we are going to pick up the HR of the signal. So is it clear?
Yes.
So if you see the difference between the panel interlocking, yes. So if you see the difference in the operation, here he need to operate the points individually. He need to set the points for parallel position of the root. Then only the signal can be taken off. Here he need not bother about that one. He should know for which route he is going to take off that signal. You need to press that signal button or turn the signal knob to reverse and then press the signal button. Whatever the points that are falling in that route, those are going to automatically correct. So once the point operation has been complete, the checking of the route, locking of the route, so those will be similar for both the things. Here only in the way in which the operator operates differs between panel interlocking and root relay interlocking. So in the RRAs, the points are required to be operated manually for point testing and automatically through root initiation. So whenever there are 3 positions of the points, we are going to keep in central position for its automatic operation. When there are only 2 positions of the point available, normal and reverse, so that will be indicated by the corresponding relays NCR and RCR. So this is the 2 position knob of the point, and this is the 3 position where we need to keep in the central position for automatic operation of the point. And these are the common buttons available on the panel. So we need to press the concerned point button along with the common button. If I want to throw for normal, I need to press along with NWWN. If I want to throw the same point for reverse, the point button with the common button for reverse, RWWN, has to be pressed. And releasing of the root, so as we have discussed earlier, on passage of the train, the signal will be automatically replaced to on. So how it is replaced to on automatically? Yes, can someone please tell me?
Controlling track.
Yes. So right. So once the train has passed, how do you know whether the track circuits have been occupied or not? So this is a signal route. So for a train, the SM has given a signal. SM has cleared the signal. So for clearing the signal, what she should do, the knob of the concerned signal, you need to reverse the concerned knob of that signal. Now the train has accepted the signal. So it has passed that signal. So this passing I will know by the dropping of this control track. Once it has passed that signal, then this same signal should not be used for the second train coming. So if you see, if you just clear the signal and if it slips off, so the same signal should not be accepted for the other trains that are following it. So for that, how we can prevent this? How can you prevent this? Because once the train has accepted the signal and passed away, the controlling track is down. Once it has passed completely, again the controlling track is up. Now the signal, is it possible to signal to clear automatically again up? Because all of the conditions are satisfied. The condition of points are not changed, LCKT is not changed, so all of the conditions are satisfied. So the signal will re-clear or not?
No, sir.
Why it will not re-clear? What is the condition that has not been satisfied? What is the condition satisfied for train number 1 and what is the condition not satisfied for train number 2? So here, what is the feature we are discussing? If a signal is cleared for one train, that is meant for only that one train. That should not be used for the next following train. So one signal, one train, we are going to permit the movement. How this is being achieved?
TSR.
How? In the TSR. Okay, there is a relay, but how we are going to achieve it? So I am clearing the signal for a train means what? I am turning the signal knob to reverse. Okay. So the signal knob is turned for this particular signal to reverse. Now the train has passed. So for the second signal, he need to normalize the signal knob and then reverse it again. That is the act that I am expecting from the station operator. For every signal, for every train, for clearing the same signal, you need to do this operation of normalizing the knob and clearing it afresh for the next train. So this I am going to ensure by suppose keeping a relay called TSR. This TSR I am going to pick up by the normal condition of the knob. And how I know whether the train has passed the signal or not? By the controlling track. If the controlling track is in up condition, it has not passed, it has not accepted and it has not passed the signal that we are assuming. Suppose I am going to keep the TSR in this manner. If I am, and this TSR I am going to use in the HR again. HR means for clearing the signal. So for clearing the signal, if I use this TSR, for clearing the signal, I need to reverse this knob again. So when I reverse this knob, this is going to fall again. So if I am going to use this TSR in the HR, it is going to drop the HR. It is not going to permit for clearing the signal. So what I am going to do, I am going to give a stick path with its own front contact. So when I clear a signal, this condition of the knob normal is not satisfied, but TSR remains in up condition only by the front contact and the pickup contact of its own relay. With these two conditions, it is going to remain in pickup condition. So this pickup condition of TSR is going to be used in HR circuit, and I am going to pick up the HR for clearing the signal. So now once the cleared signal, when it is accepted by a train and when it has passed that one, this controlling track is going to be dropped. So once the controlling track is in drop condition, the TSR is going to fall again. So once it falls, this HR is going to be dropped. I am going to give on aspect for the signal. And for again giving the same signal for the next train, he need to pick up the TSR. For that, he need to definitely normalize the knob. Otherwise, the TSR is not going to pick up. So for every signal, I am going to ensure that for clearing that one for the next train, he is reversing the signal knob and then normalizing it again. Once he normalizes only, it is possible for him to clear the signal for the next train. So in this way, I am ensuring that one signal is meant for only one moment or one train moment by using the TSR relay. Is it clear?
Yes, sir.
Yes, sir.
Now the train on entering and clearing the route, the track. Yes, the track circuit will operate sequentially and the sequential relays UIRs are in up condition. So normally all the UIRs will be in down condition. So this I am going to prove while clearing the signal in HR, all the normal status of the relays. Once the train passes over the track circuits in a sequential manner, they are going to pick up one after the other. So once all the UIRs has picked up, through this UIR pickup contact, I am going to pick up the ASR. Once ASR picks up, it is going to again reset this UIRs. It is going to drop the UIRs again. So this UIRs I am going to ensure that whether the train has sequentially gone or not. So when the train completely clears the last backlog tracks and the signal knob normalized, the concerned ASR is going to be picked up. The route is now released. The route is now released. What do you understand by that one? What do you understand by that one? Once I have picked up the ASR?
Points are set free.
Yes, now the points are free. Now they can be operated if required for other movements. So the ASR picks up and the sequential route release will drop. So similarly for RRI, where sectional route release is provided, TLSR and PRSR are provided. So some zones may be using a different nomenclature or different names for this one, but the logic in which how they are operated will be similar to this. So here the entire route I am going to divide into sections. So when I'm going to clear this signal, so I'm going to log the entire section. Normally, if I don't divide into these particular subsections, this route will be released after the train has cleared this entire path. Now, this has got drawback. Now, until the train clears the entire path, I cannot use any one of these points. So, where the flexibility of the yard will be affected. So, once this is divided into particular sections, once the train has passed that section, now I am going to make this section free. So, these points can be used for other movements in the yard, which increases the flexibility, movement flexibility in the yard. So here in major RRIs and all, we are going to provide this feature called sectional route release. So likewise, we have seen the points are held up in the route and all. So how about the points in the overlap and why we need to held these points? Why we need to log these points? So if I am going to clear the signal, it is an authority for the local pilot to go up to the next signal. So in signaling, not only this path, we are ensuring that it is free from any obstruction or it is in a locked condition. We are going to see some extra margin of that is also in locked condition or it is in free condition. So this we are going to check in the OVSRs by using the OVSRs. So these OVSRs will be named after the corresponding starters. So we are ensuring that the OVSRs, once they are in drop condition, that means these points are in locked condition. Once the train has completed the movement, if it is going to stand here, so after some fixed time delay, then only we are going to permit this alteration of this point position. So once the signal has been taken off and we can cancel the signal, or the signal has been accepted by train and it has passed, then also we are going to pick up the ASR. So a signal can be cancelled by simply turning the signal knob to normal or by pressing the signal button on the emergency signal cancellation button. But route releasing will depend upon what is the approach locking that is being provided. So what do you understand by means of approach locking? Hello, are you getting me?
Yes, sir.
So what do you understand by approach locking?
Approach locking is a type of locking which prevent route alteration in case of approaching train.
Yes, suppose this is the track signal available. Now the train is somewhere here. It is approaching the signal. So we are providing certain locking. That means if the train is within this area, we are not going to change the route further. We are not going to alter the route immediately. So if it is in the approach of this signal, if it is in this area of approach, we are not going to alter the route whatever is being cleared immediately. If it is not within the approach at all, it is very far away, we can permit to change the alter the route immediately. So this type of locking we are providing when the signal is being approached, that we call as the approach locking. For that, for each signal, we are going to define what is the approach track length and all. If the approach track length is sufficient available, and if it is an unoccupied condition, then we are going to release the route immediately. If it is an available and if it is an occupied condition, we are going to release the route only by giving a fixed time delay. Or if it is not available, or if it is available but it is insufficient length, we are going to give fixed time delay. After that fixed time delay only, we are going to permit for releasing the route. So these are the cases for cancelling the signal when sufficient track circuit is provided in the approach. The route is released without time delay when approach track is clear, or it is released with time delay when this approach track is in occupied condition. Where sufficient length of track circuit is not provided, like the home signal where only the calling on track is provided, route release is possible with time delay only, irrespective of the position of the train. So whether the calling on track is occupied or it is unoccupied, if you are going to give a dead approach locking, that will be ensuring that only after some fixed time delay only it can be changed. The length of the approach track depends upon the section, permission speed, the type of the signal in the counters. So we are going to define the approach track length for each signal. It's a starter, loop line starter, the berthing track. If it is a sun signal, one track circuit before the signal. Like that, we are going to define the approach track length and all. And we are going to provide counters to register the emergency operations and all on the panel. So this is the sequence of operations and the various features we are supposed to provide on the panel as per the specifications. So is it clear? Do you got any doubts? Hello?
Clear, sir.
Clear, sir. Clear.
No, sir, no.
Yes. We are going to discuss these 4 points. Wait 1 minute, I will show it. These items in the relay interlocking. Are you able to see the screen? Hello?
No, sir.
Okay, today we have discussed in brief about the relay interlocking. So what do you understand by relay interlocking? What do you understand by relay interlocking?
The interlocking is the time of interlocking, which is achieved through.
Yes, it is
Relay.
achieved through relays. So here we are quantifying the each and every act on the panel by means of status of the relay. So by means of relays, we are going to achieve the interlocking. So this is being achieved directly by the levers in case of mechanical interlocking. So in relay interlocking, we are achieving the same thing by using the relays. And we have seen different types of the relay interlocking, either it is route setting type or non-route setting type. we have seen various differences between the root setting type and non-root setting type, and in what way both differs in the from the point of operator. What way the sequence of operation differs. That is what we have seen in brief today. So in the next section, we will be seeing about the signaling plan and the point operation and various circuits in parallel interlocking. So if you got any doubt, you can ask me. Okay, if nothing is there, thank you. Tomorrow we'll meet.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Very helpful.
Thank you.
Thank you, sir.
Sir.